Before we get into the details of limits, it helps to have a visual understanding of the problem that limits try and tackle. Generally, when we think about a graph of a function, think of a nice continuous curve, like this. It can be easy to forget, however, that we rarely have infinitely many data points when determining a pattern in data. This is important because it means that if we want to know what the graph looks like near some particular x value, say x0, we only have a finite number of points from which we need to figure out that pattern. So instead of a whole graph to work with, we might have something more like this. Now you may think that it's obvious what the curve should look like, given these particular data points. After all, you've already seen the end goal. But it's important to realize that there are actually lots of different possible curves that go through these points, but all hitting different y values at x0. For example, this curve goes through all the points, but has a much higher y value than our original curve. This curve hits all the points, but has a much lower y value at x0. And here's another curve, and another, and another. At first, this might appear to be an issue of scale. Maybe the data points we have aren't close enough to the x0 value. Maybe if we had closer points, we wouldn't have this issue. This is close, but it wouldn't quite solve our problem. Let's place a few points closer and then zoom in and have a look at what happens. Although we're closer and we have better data points, we still have the same issue. For example, look at this curve, or this curve. Again, we can draw lines through all the points that nonetheless don't have the same y value as the original curve. Although zooming in didn't solve our problem, we might observe that the amount of variance in the vertical direction, that is to say, the amount the y value was off from the original curves, is likely to be smaller. So although the problem isn't solved, it has been mitigated somewhat by getting closer data points. We could repeat this process of zooming in and getting closer points to reduce the span of error, but how far do we zoom in? And no matter how far we do zoom in, we'll always have some kind of error, right? Indeed, we'd need to zoom in infinitely far to lower the error to be infinitely small. But as we mentioned at the start, we can't get infinitely many data points. This is where the mechanic of limits comes into play. At its core, a limit is a mechanism that allows us to get infinitely close, also called arbitrarily close, to something. Or, another way of looking at that, it allows us to iterate something infinitely many times, like this zoom in. So when you need to do something infinitely many times, or get infinitely close to something, your first thought should be limits.